Aloha, Richard Halverson here. This is ICS211. And today I'm going to cover, in this video, I'm going to cover the section 14.4 hash map and section 14.6 hash set. So at the end, there are challenge activities in each of those. So if you're having trouble getting started on those, you can see that. That's what this video is for. All right, let me share my screen. And I'm going to put this down for, I'm going to try out this presentation view because it looks kind of interesting here. Okay, so first of all, hash maps. A hash map is like a dictionary in Python, associative array in some languages. Basically, you have a key and a value. And so it allows the programmer to map keys to values. So in this example, we are creating a new instance of a hash map called state population. I make this bigger. Yeah. And so this is how you create a new instance of a hash map. And there's two primitive. No, there's two class types in the definition of it, and the first one is the type of the key, and the next one is the type of the value or the data. So in this case, we're doing state population, and the first one is going to be the state, like California. The second one is going to be, I guess, the population of California, which is an integer. So that's how hash maps work. And so here's an example of a hash maps put method to replace a value. Here's adding a value. Putting to map keys to values. Okay, putting is and then putting can also replace the value. See, if you're adding new values, you use put. If you're replacing values, you also use put. And here's an example of using the contains key. So this method is used to see if an actual key value is in the hash map. So, like there's states that are not in here, or in states that are in there. That's what that's for. Here's an example of where we are recording distances at particular distances and times. So this is the distance and this is the time. This is the distance and this is the time. And here we are inserting 3 in there. And then what you can, then it queries asking, it queries it just once. No, the loop is, okay, let me run this and see. Here it reads a new one. Okay, so it loops until the user enters a 0. I've actually I've taken this program and put it over on Eclipse in this one, not this one, but this one. And you can see these much better when you actually have an interactive environment here. And here, the problem with this environment, of course, is that you have to put all the inputs here, and these mean nothing. You don't see the inputs there, and it's kind of confusing. So if we look at it, I've re-implemented it here. So when we run this one, this is test project 2. Let's see, run test project 2 here. So we've loaded up these distances and times, and so I can put it. Let's see, what's distance for 5 is 23.14. What's the distance for, is there a 7? What happens when you put a wrong one in? Null minutes. 25 is 120.75, and 0 is it stops. So anyway, that's an example of a hash map. Very, very useful. And so these are the common hash map methods. There's put that we just saw. The key already exists, replaces the value. This puts only if it does not exist, it puts only if absent, so it won't overwrite. So it's a key and a value. This gets the value, otherwise it returns null. This says if it contains the key. So this gets the value of that key. This returns true if it contains the value, and so on. So make sure you understand these and use them. Here is a challenge activity. Let's get started. I'll get you started on this. Let's see. Let's in this first one, looks like we're loading up a bunch of airport codes, which is the key, and then these are where the airports are, I guess. And then it prints out where GRX is, which is this. Prints out where first it prints a GRX, and then it prints the city, and then for this one and for this one. Oh, this puts in a new one in this. Okay. All right. So let's so that's the easy one. I'm going to start this up, and I'll tell you what, I'll do number 3. Okay. So we create a new instance of a hash map calling it country capital, and then we're going to use a scanner, and we're going to put Spain. These are the capitals of these countries, and then we're going to remove Egypt and remove Peru, and then we're going to read in a country, and unless the country equals exit, we will see if our hash map contains that country. And if it does, it prints out the country followed by a colon, followed by the city, the capital. Otherwise, it prints out an NA. Okay, and then it loops until it exits. So these are the 3 inputs. So what are we going to print out here? First of all, we're going to print the Brazil is not in there, is it? So we're going to say Brazil colon space N/A. And next we're going to do Peru colon. Peru is not in there anymore, N/A. And the third one is Chile, CHILE. And that one is in there. It wasn't removed. So we're going to do Santiago, SANTIAGO. Enter. Let's see if this is correct. Yeah. Okay, very good. So you can do the rest of them. All right, student grades. This is I'm going to do the labs in a different video. I think I've already done this video. And so I'm going to go into HashSets, and I'm going to do the lecture and the challenge activity for HashSet. All right. So a set, this is very useful. Sets, they're just called sets in other languages usually. A set interface defined within the Java collections framework defines a collection of unique elements. So you put elements into the set, and you can only put it in there once. You can test if the element is in there. You can remove the element, but that's basically it. The order does not matter. It's just whether it's in there or not. That's what sets are. So we have a add, we have a remove, we have a contains, of course. So this adds an item, removes an item, checks if an item is in the set. So here we're creating a new hash set, just as one key value, you might say, or one class here, and one to define, and this is the name of it, and this creates the new one. This is a hash set of strings, and so this is, I guess, storing books, and then you can test to see if the book is in there, and so that's what this is. So click through this, make sure you get the points. Same with this one. This shows add and remove. Here we've added 3, and then here we're going to remove 1. We're going to try to remove it, but it's not there. So this result is false. Here it tried to add this, and it's already in there, so the result is false. That's why we see false twice here. You can click through this to make sure you understand it, get those free points. Here we're guess the numbers. Okay. This is also difficult to follow because we put all the inputs here and it loops and asks you questions. So lo and behold, I implemented it over again over here, test project, and that's this one here. Let me just close this one. So here it is. Do I have this? Shoots. Let me go back to here. This I gave it away. It doesn't matter. This is just an exercise. This is this should say contains. This is what we start with. We start with this. Yes. Okay, so this is what we start with. This is we create a hash set. We add 3 things to the hash set. These are integers, so we add 3. Can I make this bigger? Maybe I'll figure out how to make it bigger next time. And then what we're going to do is we're going to guess to see what numbers are in there. So we loop and we ask for let me clear this. We ask the user to enter a number between 1 and 10, and then this thing is gonna, if it's in there, then it'll remove it. If it's not in there, it'll just say it's not in there. And you win when you have removed all of the numbers. Okay, so there's 3 numbers in here, and you're supposed to guess them. So let's run this and see what it looks like. This is test project. This one. Okay, so enter and so 1, 3, and 5 is in there. So I'm going to try 1, and it says, good guess. Now there's only 2 remaining, and I'm going to try 2. Oh, incorrect guess, 2 remaining. I'm going to try 3. 1 remaining. I'm going to try 5, and I won. I got them all. Okay, now what we're supposed to do here is first we see if it's in there, and if it is in there, we remove it, and we're supposed to see if we can modify the program to only use remove. And the answer is very simple. If it's in there, we're going to want to remove it anyway. If it's not in there, it's not going to do anything. And it turns out if you look at these common hash set methods, the remove, if the element exists, it removes it. If the element does not exist, it returns false. Okay, if the element exists, it removes it and returns true. So it returns whether or not it was successful. And so since we're going to remove it anyway, we can just make this be remove. And we don't even need to have this second thing here. So if this works, then it's removed, and we can say good guess. If this doesn't work, it's not removed, and we can run this by running it again, and we can do the same thing. 1, 2, 3, and 5, and you see that we get the same result. Okay, that's common hash set methods. We have a challenge activity here. Let's do this. I guess I'm about right here. It's okay. Okay, for this one, let's look at the first one and see. Okay, so we create a new hash set called languages, and then we load, using next line, we load up the languages. Are they already in there? Well, let's, that's right. This is the end. Okay, let me just, let's see, I think because, okay. All right, I'm gonna do the first one because I don't quite understand what's going on here. Okay, we're gonna input this. I see. This returns whether or not it was successful adding it or not. And since it's a set, we can only add it once. So here we run this, we try to add that and we are successful, so we've added it. And then we try to add it again and we're not successful, so it prints out n. And then we try English and that's successful, and then we try Spanish and that's successful, Bengali is successful, Hindi is successful, and then we're done. Let's see, does it print anything when we're done or just done? Okay, so this uses the compare to, and so you recall. Oh no, you'll learn that in the video. You can't use. You can use equals. You can use compare to, but you cannot just use the seeing if a string class is equal to a literal, a string literal. That doesn't work, and it has to do with the fact that this value is read in using next line rather than being assigned a literal value. So anyway, so we use compare to, and of course compare to, if it's equal, if this is equal to this, then it's going to return a 0. Otherwise, it's going to return a positive number or a negative number, depending on whether it's lexicographically greater or less than this whether this is greater than or less than this. And so if it's not equal to 0, then it's not equal to done. So then we output an A if we were able to add it, and if it's not able to add it, it comes down here and outputs an N, reads it again. At the end it says size. So I gotta say size, colon, space, and how many are in there? Well, it looks like 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, it's 5. Enter. Okay, check. All right, very good. I'm going to let you do the next two. Okay, so that's I'm going to do this 14.7 in a different video. I'll probably do it right after this. And so that's it for this video. I will come back next. My next lecture video is going to be on queues and decks. So hope this helps. Thanks for watching.